Welcome everyone to today's webinar on the actual performance of buildings, precious data for both citizens and system operators. I am Mäkelä. I am the Executive Director of smartEn, a European business organization of around 100 companies offering technologies and services for consumers to become active and to become flexible. Together with EuroACE, the European Alliance of Companies for Energy Efficiency in Buildings, we decided to co-organize this event. Why? Because energy efficiency and demand-side flexibility in buildings, in particular in buildings, go hand in hand, and they should go hand in hand. Until now, European legislation, in particular the Energy Performance of Building Directive, has focused a lot on trying to reduce consumption. It's a very important objective. We needed to keep that objective. We needed to implement and make sure that this renovation wave is actually aiming at that objective. And at the same time, we needed to also ensure that buildings are flexibly adjusting their remaining lower consumption, but also their storage, their on-site renewable generation in a flexible, time-dependent way. Only if we have both efficiency and demand-side flexibility together, we will make sure that buildings are going to actually provide the best benefits to a cost-effective achievement of our climate neutrality objective. And we are very satisfied that the current revision of the EPBD, so the Energy Performance of Buildings Directive revision, is going into that direction to expand the original scope of that piece of European legislation. But let me allow to give you a few figures on the relevance of this approach, of this expansion of the approach. Together with DNV, last year we published a publication to quantify the benefit of flexible consumers, so not only of buildings but of all consumers in 2030, looking at the increase in the electrification of the EU energy systems. And we calculated that we expect in 2030 a peak demand of 750 gigawatts, huge figure. But thanks to the flexible contribution of all end users, including buildings, of homes and commercial buildings, we can have 160 gigawatts, meaning 22% of that 750 gigawatts of upward flexible power, so the capability of these buildings to increase generation or reduce demand, and also 130 gigawatts, meaning 17% of that peak demand of downward flexible power, so the capability to decrease generation or increase demand. This is an extremely important time-dependent fluctuation and adaptation of consumption and on-site generation pattern of buildings that indeed will ultimately increase the efficiency of the system and reward consumers, both occupants and tenants of the buildings that have these capabilities. This is the context of this event, and the specific focus of this webinar is on the need to quantify, to measure the actual performance of efficient and flexible buildings. With the performance, we mean the carbon performance, the energy savings, and the flexibility performance of a building. And imagine a future, hopefully not that far from us, where all buildings will have a digital ID, sort of EPC 2.0, maybe available also on our smartphones, which will provide this information for the entire buildings, not only for individual assets, but for the entire building, with historic values, with current values, and eventually also projections. And this information, this measured, quantified information, will be very relevant for different players. It will be extremely important for occupants, being them owners or tenants, to know exactly the actual measure performance of their buildings, which would increase their understanding of the performance and the potential of their assets, and eventually drive towards investment to improve the performance of their buildings. It is also extremely important information for market players, imagine aggregators of demand response, which will have an easy access to aggregated information for each building, which will allow them to have tailored offers to consumers. And last but not least, is going to be extremely important for system operators, because if they have access to the aggregated information of the flexibility and the energy performance in actual terms of buildings in the area where they are responsible for, this will allow them to shape more solid 10-year network development plans and to know which resources they could procure in a market-based way to avoid, for example, congestion, and to balance in a most cost-effective way the grid that they are responsible for. Today's event is going to be indeed shaped around three main pillars. After me, there will be a presentation and the introduction of the political top context, indeed the energy performance of building directive that I was referring to. It will be done by Marion Malafosse, the policy manager of smartEn. Luckily, the senior commission officials that were expected to make this presentation today are all busy in an energy working party trilogue negotiation for the energy performance of building directive, so they are of course excused for these reasons. And then we have two other sessions. One will be presentation of real cases on how the actual quantification of works and how it can benefit both citizens and system operators. And then we are going to have a discussion with 3 system operators on exactly this use that they can have of these flexible, this quantification of the performance of buildings for their own purposes to optimize the use of the grid. 2 house rules. The first one is that this webinar is going to be recorded, so please do not hesitate also to share the recorded link further. And then an important information that we wanted indeed to have some interaction with the audience. There will be Q&A sessions at the end of each panel, and please submit them via the chat in the GoToWebinar platform. I would like to conclude at the stage, and I'm very happy to give the floor to Marion Malafosse on the revision of the energy performance of buildings.
Thank you very much, Miguel, and good morning to everyone. So indeed, I'm Marion Malafosse, Policy Manager at smartEn. I will have the pleasure to moderate the first session with the selection of real-life projects. But before, indeed, I will provide a bit of political context, as it is extremely topical currently. As you all know, the EU is about to finalize the revision of the energy performance of building directive. The objective of this directive is to accelerate the renovation rate of building and also to achieve a zero-emission building stock by 2050. But as mentioned before by Miguel, the revision of the EPBD is not only about energy saving, but it is also about setting buildings onto the path of becoming more flexible and an energy asset that is part of the whole energy system. But what are we talking about when we're talking about an efficient and flexible building? First, it is a building that has a high energy performance, that is better insulated, with an efficient energy use of this energy that is used for heating, for cooling, lighting, or to run the appliances of the building. Second, it is a building that operates as an active part of the energy system. So it's no longer a passive consumer of energy, but it is an active participant. It can be this active participant by being able to interact and support the occupants of the building, but also the grid by varying its consumption, its generation, and storage of energy. And there are a lot of assets behind the meter that are already present in buildings and that will also be more and more present in buildings that allow them to become active. For instance, we have heat pumps, home batteries, smart dishwashers, EVs that are smart or bidirectional. We have also generation of renewables with solar PVs on the rooftop. And if all of these assets are smartly managed, then they can help to optimize the consumption, the use of energy of each occupant. This is also, as mentioned, a valuable resource for the grid, and we will see that further later on in the event. So this evolution towards smart assets and the smart management of energy within building is of course supported by digitalization. Digitalization is really at the core of a flexible building. And so there is a need for increasing the level of smartness in building. The EPBD goes into the right direction to stimulate efficient and flexible buildings. And in the next slide, we see that there are 3 building blocks that support this evolution. First, we have provisions that really start considering buildings as assets that can support the energy system. And just to name, this is not an exhaustive presentation, but it's to focus on the key provision. And if we look at the zero emission building definition, which is also the objective as to where we want our what we want our buildings to become, it is now also taking into account the electricity that is coming from the grid. So that means, and that opens the possibility for buildings to optimize the electricity that they consume from the grid in a way that will make them efficient, but also supportive of the optimization of the grid. So as a result, they're no longer considered in isolation, but they're part of the energy system. Second, of course, as mentioned, if we want the building to become smart, it has to be equipped with the right assets that are behind the meter that are within the building. So here we have several, again, provisions that will support the rollout of EVs, electric vehicles, the heat pumps, solar panels as well, but building automation control system that will have also the capacity to react to external signals and adapt the consumption of the building. With these 2 pillars, indeed, we are in the right direction for buildings to become efficient and smart. But now we have to be sure also that we will be on the right track. We have to make the best use of the flexibility capacity of a building. And for that, we need to quantify how well the building is performing. Meaning we need to know how much flexible capacity we have. We need to know the carbon footprint of the building, not through theoretical value, but through the quantification of the actual performance. Without this information, we cannot truly profit from the benefits of efficient and smart buildings, both for the occupants, but also for the system. And here again, the EPBD is opening the door to this evolution through the smart readiness indicator, through provisions to access the data of the buildings, and also by introducing indicators on operational greenhouse gas emission as part of the MEPS, which will also favor a real-time carbon quantification. There are also ongoing discussion to include the demand side flexibility capacity of a building as one of the indicator of the energy performance certificates. So even if this is opening the door and it is a timid evolution, it goes still in the right direction. But luckily for us, and the good news is that we have the technology solutions already in place. They already exist, and they will support and amplify also this evolution that we have here through this regulatory framework. So for these technology solutions that already exist, I am very pleased to welcome our 4 speakers for the first session. So Barry Lynham, Managing Director of Knauf Energy Solution, Agustin Garcia del Castillo, Director of Sustainability in Europe of Johnson & Controls, Mariangela Acquafredda, Transformational Leader of Digital Energy in Schneider Electric, and Jason Avramidis, Director of Innovation and International Flexibility Markets at OakTree Power. Each of them will present real-life example and there are business cases that are measuring and quantifying the actual performance of building and the technology solutions that they are providing, as well as highlighting the benefits for the users and the system. So without further ado, let's start with Barry for his presentation from Knauf Energy Solution. Please, Barry, the floor is yours.
Thank you very much, Marion, and thank you to both EuroACE and to smartEn for organizing today and inviting us to speak. So I'm going to be talking about, yes, how we can make performance visible. If you go to the next slide. So what is Knauf Energy Solutions? Just very quickly, we're one of these famous one-stop shops for energy efficiency renovation. So we do large sort of renovation projects where we might renovate 100 to 200 homes at a time. What makes us a bit different is that we're backed by a breakthrough digital technology that allows us to understand the exact energy performance of the house pre and post retrofit, allows us to give a guaranteed offer to our customers so we can guarantee the savings that we're going to make in the projects. And how do we do that? If you go to the next slide, we do that through using smart sensors, which capture critical data from the house, things like CO2 data, indoor temperature, humidity, VOCs, and energy data from the house, which we capture and we send up to the cloud, where we use, if you see the next slide, where we develop two, on the next slide. Can we just go to the next slide, please? Thank you. Yeah. So where we take that data to understand the house, and we develop two kind of key critical data points that we use for our projects. One is what we call the megawatt hour graph, which is one on the left, and the other we call the energy demand indicator. Just to quickly explain what we do on the left side. So if you look at the graphic on the left side of the screen, in the middle you have the black line, which is the moment that we renovate the house, and to the left, the gray area is the energy being used by the home pre-retrofit. And the red line is the algorithm that's understood and learned the house, and which we blind the data and we ask it to guess the energy use for the house, so we understand whether our algorithm has fully understood the performance. And obviously, the closer those two lines are, the better we know that the algorithm has understood the performance. But the interesting thing is post retrofit, and that's on the right side, is whilst we continue to measure the gray area, which is the energy use of the homeowner post retrofit, whether it's a new person living in the house or whether they've changed their behavior or whether they're now at home because they've retired or whatever, doesn't matter to us, because the question we ask our algorithm is, versus the energy efficiency of the house pre-retrofit, under these new circumstances, how much energy would the house have used? And that's the dotted red line. And the yellow area after renovation is the amount of energy being saved day after day after day because of the retrofit. It's like an energy efficiency meter. It meters the energy efficiency impact of the renovation, just like we would measure the kilowatts produced by a new solar panel on the rooftop. And so we can really understand exactly what the project has delivered. And on the right side with the energy demand indicator, what we do is we can also normalize that data and give what we call a kind of like a real energy performance certificate to be able to actually show the real performance of that building as an asset pre-retrofit and then after retrofit. So we can see exactly what the change has been in terms of the energy efficiency of the house and therefore its impact, for example, future on the grid. If you go to the next slide. But whilst the technology we're very proud of, and we know that it's one of the first in the world that can measure real performance at the level of single family residential homes, it's not really the technology which is perhaps the most exciting thing here. What's really exciting, of course, is the fact that for the first time we can now see clearly, and that really matters. And I think one of the things that energy efficiency has always suffered from compared to energy generation, it has been very hard to be clear what exactly does a retrofit deliver, what exactly do renovations deliver to customers, to governments and to actors. And if you can't see that, it's often hard to give value to energy efficiency and to see it as, for example, a grid asset if you can't really see it. And so we started to see things. And what have we started to see since we started looking at buildings with this kind of technology? And if you go to the next slide, the first thing we started seeing was that there are huge gaps in terms of what we think is happening in the built environment. So this is a series of buildings that we either retrofitted ourselves or were involved in the retrofits, or where customers brought us in because they had some problems with retrofits and asked us to look at their homes and find out what was going wrong. And I'll just do two of the houses here, which I think are the most interesting. And if you look on the bottom side there, if you look at house one, the normal energy performance certificate was telling us that this house is 687 kilowatts per year in terms of its energy demand. And when we measured it, if you look at the top for house one, it was actually 143 kilowatts per year. And you can see that that's a vast difference. You have a home that, if you were presuming and thinking about what kind of your grid position needed to be to manage that electricity demand, if you turned it to electrical heating, while the current data that you're getting is giving you very poor information. And unfortunately, if it was only one direction, that would make it easy. But if you look at house four, that was a house that was done by another organization for one of our customers, and it was meant to be a deep retrofit and deliver 20 kilowatts per square meter and be a very energy efficient home. But our customer was worried that the actual energy bills of that house were significantly higher than expected, and so we went in and we measured that house to see where it was, and what we saw is actually that house was at 220 kilowatts in terms of its real performance, so 11 times more energy demanding than it was supposed to be. And so what you're seeing is that currently we have a huge gap in terms of what we're learning from the existing sort of data points and what we're seeing as we go now with a very accurate sort of view of the real performance of the building. And that's obviously quite an issue. If you go to the next slide, it doesn't only pertain to retrofits. This is a series of houses that we looked at, new build houses that were supposed to be quite low energy houses. What we found in these houses was, on average, they were 2.5 times more energy demanding than we expected. And of course, if we're thinking in the long term about our sizing the grid for the heating demands that we're expecting, if what we think we're seeing is one thing and what we're actually seeing is a completely different demand for energy, well, that's going to create some significant problems in terms of our long-term thinking. And one of the things we notice, it gets even worse, because if you look at the right side of this slide, that's a report that was done on the actual coefficients of performance that we were seeing from a series of heat pumps. And what we saw was that the actual coefficients were quite often quite lower than expected. And perhaps one of the big drivers of that, we don't know, but maybe one of the drivers is the fact that the presumption of the actual energy efficiency of the homes is quite different than we expected. But of course, from a grid operator's perspective, this is a double problem, because you get a high level of demand than expected, and that then affects the efficiency of the heating systems. You get an even higher demand for electricity than was expected. And so that's why I talk about the double whammy effect here of electrification. And you go to the next slide. We're also seeing, for example, in our projects that the sizing of heat pumps is often not exactly as we would expect based on the current data. Sometimes too big, sometimes too small from what we see in our data. And I think it's this electrification of heat, which of course is the big challenge with this difficulty and this problem with understanding the real performance of buildings. In a world of gas boilers, well, it's may lead to higher use of energy, but the sort of run-on impacts on the full energy system are going to be much less. But if you go to the next slide, when we try to look at what electrification of heat means for the grid, we start to see that these kinds of misunderstandings of real performance could have quite dramatic impacts in terms of grid, because actually, as you move to electrification of heat, obviously heat isn't a static need, right? We don't need heat at the same level across the whole year, particularly in the Northern European countries. And we try to have a look at kind of how, based on our data from our projects, what would be the impact of a full sort of electrification of heat. In this case, we're looking at the UK, but we've also done it for Europe as well. And what you see is, of course, the U-shaped curve, because we're expecting a lot of heat demand in the winter on the left side compared to today's more flat demand for electricity. But it's more the right side of the right graph, which is more concerning, where what we did is we modeled a future energy system, which was a third wind, a third solar, and a third nuclear. And we noticed that the problem is that whilst you have this demand curve, which is quite U-shaped, you of course have a supply curve, which has major troughs in winter moments when you have low wind and low solar, which matches this peak demand in terms of heat on cold winter days. And what you actually see, therefore, is that trough day and that peak day is setting your need for full generation capacity. And what we noted in our in this study, and we don't pretend to be energy specialists, and so we obviously were looking at other people to look at this and to take from it. But the direction is quite clear, is that you have this big challenge of energy efficiency, sort of energy and electrification of heat in terms of generation capacity, because you have to manage that moment of lowest production with highest demand, which sets your generation capacity. And if you go to the next slide, but the good news from an energy efficiency perspective is what we start to see is that, of course, in that world, energy efficiency is no longer just about saving energy. It becomes also be critically about saving energy and generation capacity. And what modeling suggested in this case, that a kilowatt of demand reduction actually delivers 5.2 kilowatts of saved generation capacity. And we could go even further if we looked at how we could be flexible with that heat across the day and get through some of those peaks through shifting during the day as well. And we can imagine that could be even more improved reductions through this demand reduction on generation capacity. But what it kind of really tells us is that in this future electrically heated world, being able to understand and predict the actual demand that the housing stock will deliver, the ability to understand what renovations will deliver to the grid, become absolutely critical to be able to size and to make the transition to a low energy grid possible and cost effective. If you go to the final slide, just a few things that I think, it is our view that the ability to see clearly is really, really important, particularly as we electrify heating. It allows us to prove that energy efficiency actually does deliver and at what level it delivers, so we can optimize both the energy efficiency strategies to our generation strategies. It ensures that the subsidies that we will put into the market to make this transition possible will actually deliver. It helps us to make sure that heat pumps and houses are ready for heat pumps and sized correctly. It supports the sizing of the energy system correctly, because we can finally understand exactly what things are delivering. And it's saying all that brings and together that the ability to see in this space where it's been so difficult to see and understand exactly what's happening, provides that real performance, provides the possibility for delivering a much more cost-effective transition than without it. And so we see this as a key part of the transition, is really bringing some visibility to energy efficiency at the single-family house level, and being allowed that to drive our decision making using facts and information, rather than where we are today with very, very blurry vision of what's actually going on. Thank you very much.
Thank you very much, Barry, for this insightful presentation, and for showing indeed that the importance of being able to have prediction, visibility and understanding, because this is indeed key for planning, for the grid, for the system, but also for capacity. One follow-up question I do have for you, because you show us that you have the technologies available to do this measurement, and you have this understanding of what we are actually consuming. So it's no longer in theoretical terms, but what are for you the barriers that you would see for using this data into the planning of the capacity of for generation for the grid? How to take that the next step?
Yeah, so I think there are two key challenges. One is that today the Buildings Directive doesn't allow current energy performance certificates to be replaced by real performance certificates. We hope that the new revision of the directive will make it possible for member states to use real data as a complement and to put it into the energy performance certificate. So that's important. At the grid level is the lack of monetization capabilities. So the fact that today we can't, for example, play in capacity markets. So it would be, obviously, we think it'd be very interesting for the grid companies to be able to buy, for example, efficiency purchase agreements. So rather than power purchase agreements, to say, okay, let's buy a certain amount of reduced energy in the system to allow and to support retrofits to happen and to use that demand as a rosen generation. Today, we don't really see those schemes available to us, and therefore that also is a block to be able to make this work and to make that optimal position between how much generation versus how much demand, because we don't seem to have the same access to those capacity markets that obviously power generation does.
Yeah. Thank you very much, Barry. Now I will ask Agustin Garcia del Castillo from Johnson Controls to also present what they are doing in this field.
Hi, Marion. Thank you very much. Thank you very much for inviting me to this panel, and thank you also to the other panelists. Really interesting presentation from Barry and from what Knauf is doing, because we share the same approach in terms of building performance and the importance of heat pumps and electrification. So, yeah, my name is Agustin. I'm the head of sustainability solutions and service from continental Europe in Johnson Controls. Next one, please. Yeah, if I don't know if you are quite familiar with Johnson Controls. Basically, we are a building technology company. We cover many fields on the of technology in the buildings, from fire and safety, security, HVAC, heat pumps, building automation systems, and obviously energy efficiency and performance contracting. So basically, what we say is that we cover, we try to make the buildings smarter, healthier, and more sustainable. And what it means basically for the user, for the owner of the building, and from the and then from the society, and the positive impact that we can do in people, in places, and in the planet. So next one, please. Yeah, very briefly, I wouldn't spend a lot of time on this. So yeah, we are a global company, and we deploy all kind of solutions since many years. A lot of innovation experience, and basically I will focus in my presentation basically in our digital solutions in order to gather data from the customers and how we can improve the building performance of our customer, how we can make it more transparent, more connected, more digital, and at the end of the day, smarter, right? So the owners and the user can take proper decisions on the performance of the building. Okay, so this is basically how we believe the technology is impacting not only on the energy efficiency topic, but also on the CO2 emissions. Yeah, most of you are familiar with the greenhouse gas protocol and different scopes. So from every scope, we think that digitalization and technology has a big impact. Obviously from scope 1 emissions to reduce fossil fuel combustion with our heat pump solutions, to obviously one of the main sources of emissions are the fugitive refrigerant losses, and we can help and support our customer with our innovative heat pumps and with the new refrigerant liquids, very innovative. In the scope 2 emissions also with the purchase utilities, we have our digital platform, and we have our utility management service to help our customer to select the right tariff and to really optimize their energy procurement phase. And at the end of the day, the source of scope 3 emissions, we can of course support them with our portfolio of electric vehicle support, with our optimization procurement services, so we can really make a positive impact on the scope 3 and on the entire carbon emissions of our customers. Next one. Yeah, I will show here like 3 examples of our portfolio when we really are using the data to make buildings more optimized and to improve the performance of the building. The first one is one of our main products in our portfolio. Our main solutions is what we'll call Metasys, and it's basically a building automation system. Okay, what is a lead in the industry. We all recognize, and I think that we show in the first slides, Marion, that you showed that building automation will be a key factor in the entire energy efficiency topic. We have realized that making small actions really, and to really adjust and control different set points or KPIs like temperature and equipment KPIs, we can have a very positive impact on the energy efficiency of the buildings, achieving more than 10 to 20% of improvement. And as a result of implement a proper building automation system, we can achieve better operational savings, energy savings, of course, better user experience and occupant comfort and safety, and at the end of the day, increasing the productivity and effectiveness of the workforce that is working in a country, in a building. So this is one of our first solution, the building automation system. Next one. The other one is what is our energy platform, is what we call OpenBlue Enterprise Manager. Okay, basically this is a cloud solution where we are connecting different buildings all together and different equipments to really have more transparency, and this technology will enable us to increase not only, let's say, transparency, but also maintenance of the equipment, so we can really reduce expenses in the maintenance, and we can optimize as well real estate space utilization, because this platform is gathering data not only from equipment but also for any kind of sensors, so we can really have an impact on the space usage and in the flexibility of the space also. We can also make a positive impact in the technician productivity and the facility management productivity, and we can also provide reporting services, so the landlords and the owners of the buildings, they have a holistic view of all the global portfolios that they are managing. So this is a cloud-based solution, and here connectivity and data gathering are key. So this is kind of the second solution that we can bring, and then that I would like to show how digital and building performance is connected. At the end, and the last solution I bring is what we call, is a service called predictive maintenance. I can imagine you are quite familiar with that. Basically is to connect all the equipments, and thanks to our algorithms and our artificial intelligence, we are able to predict and to advance future failures in the equipment. So we can really work and plan with confidence, we can have a consistent and sustainable performance, and we can mitigate really a lot of unplanned downtime. So this is the last solution that I bring. Next one. Yeah, just a short screenshot about our commitments. Obviously, Johnson Control is present in all the main organisms that are really involved and pushing for a net zero economy, and we are really highly rated in the different institutions and rankings that we have, and commitment that we have publicly done. And we, of course, as a final summary, I would say that, of course, we are very interested in gathered building data, and when we are gathering data based on contracts with our customer, obviously we are sharing the data with our customers. So we are really happy to support, and our positioning is happy to support data sharing aligned with the European Data Act. We believe that the European EPBD shouldn't set a precedent for a piecemeal approach for data sharing across all EU member states, and data sharing, we believe, should be regulated by the Data Act alone, which is a regulation that and will have immediate legal effect at national level. It should be also aligned with different organizations like ENSO-I, which are pan-European organizations and who also doesn't want to be faced with many different national approaches. So, of course, we support sharing of data, but not sharing of the proprietary algorithm, which is really is exempted right now in the Data Act. So, yeah, this was basically my presentation. So happy to get answers and questions from your side. Thank you very much.
Thank you very much, Agustin, for your presentation. So indeed, on your last point on the sharing of data, I believe that then the issue and the topic of interoperability of the different assets that you have together is indeed key for you. Do you see, what is for you your impression on the development at the EU level when it comes to the interoperability, and how we're going into the right direction at the right pace for ensuring this interoperability of data between the behind the meter assets, the different buildings?
What we see is that there is still a lack of standardization and maturity technology wise, and depends a lot of the, let's say, the age of a building. Unfortunately, we have a old built portfolio in Europe and a lot of legacy in terms of technologies. And for us, the big challenge is to really harmonize and standardize digital solutions. And we hope that legislation will help in that sense, right?
Thank you very much. And there is indeed high expectation with the digitalization of energy and the common energy data space that is being developed at the moment. Thank you very much, Agustin.
Thank you.
So now we have Mariangela Acquafredda from Schneider Electric. Mariangela, the floor is yours.
Thank you, Marion. So good morning to everybody. I will introduce myself first. I'm Mariangela Acquafredda from Schneider Electric. I'm in charge of the strategy and the key transformation, including the sustainability for Schneider Electric in the digital energy division for all Europe. And I'm with Bertrand Detreix, that is in charge of the government affairs for Europe as Vice President. So I will ask also Bertrand to turn on his camera as well, so you can get him as well in the call. Now, we want as Schneider Electric to let our customers speak for ourselves. So the idea here is that we showcase how we are supporting an end customer based in Italy. This is an healthcare facility, which is actually in Tuscany, is the Ospedale Versilia. And of course, we are supporting this customer in the decarbonization and energy efficiency journey with our partners. In this case, as you can see, so we were asking from our customer to help him from 2 angles. One, being efficient from an energy and carbon perspective. So that's why we have been partnering with the Enesco company, an Italian one, which is able to provide energy performance contracts, guaranteeing from the initial phase of the contract the savings that we are going to generate thanks to our solutions, to Schneider Electric solutions and services. The other angle of this customer challenge was that the customer wanted at the same time keep it this efficiency alive. So not just from day 0, but also from along the life cycle of the facility. So it's not just about energy saving on off. It's not just on off, but it's really keeping this evolving and based on the occupancy, based on the behavior of the building, but also from an operational standpoint, because we can have savings also on the operations of the building. So making the building operating more efficiently. So this was really the 2 asks that the customer had from the beginning. Now, you know that Schneider, with its portfolio, is very well positioned in 3 stages. The first stage is strategize, so helping the customer also to assess, to consult on how to deliver this efficiency and this carbon savings. So we have also a portfolio behind, which is called Eco Consult, and it's also, we have a team in charge of this consulting in Schneider Electric from a carbon and from an energy perspective. The other piece is about the portfolio, right? And the portfolio is very well positioned to digitize and decarbonize each facility. So basically, in this case, we were asked not to consult, so we didn't play the card of consulting, of strategize, but we play the card of digitize and decarbonize, thanks to our EcoStructure, which is a platform in 3 levels. The first level is connected products, as you can see from the picture. So we make sure that at the field, we have all the sensors, all the controllers, all the data that are captured directly from the field, from the shop floor of a facility, to make sure we are able to measure, control, optimize all the equipments. In this case, our HVAC equipment, and also to measure the power quality, but also the energy consumption thanks to our power meters. So what we delivered was the power logic devices for energy metering, and on top of that, the monitoring solutions, the space logic devices, which are the controllers to optimize the HVAC, the facility equipment for heating, cooling, ventilation, and air conditioning. And then on top of the connected products, it's in the eco structure, we always integrate the edge control, which is represented in this case by the BMS, which is in Schneider called EcoStructure Building Operations. Why? Because this is really the core of our solution, which is able to optimize and deliver this energy and carbon saving. So it's able to optimize, control, and adapt to the real time behavior of the building. But EcoStructure is going up to the third level. So on top of that, as EcoStructure, we are also providing the building advisor, which are all the service and the digital solution, which are able to optimize also based on AI, on the artificial intelligence, and this also to keep this performance dynamic and improving year over year. So this is very important. So we really leverage the full power of the technology from the bottom, the connected products, up to the intelligence, the edge control, up to the app service and analytics, which is really where the AI, the artificial intelligence, plays a key role, a pivotal role here. So it's a full stack of solutions, fully integrated, but at the end, we don't sell solutions, we sell benefits, right? So we sell outcomes. So the outcomes behind are very interesting. In this case, and it's possible, these are the energy efficiency solutions that are able to deliver already from year one from the installation of the solution, 40% of energy saving and more than 40% the equivalent CO2 savings measured during the year one from a period that is less than 12 months, from July 22 to April 23. It's a post-COVID scenario, so even better with the real occupancy data and real operations data coming from the equipment. It's quite impressive. It's quite impressive because these savings are not just on the paper, but these are measures and also granted through this energy performance contract, which has been delivered by our partners. So that means that these are real time, these are also negotiated before the retrofit, and after, our partners are rewarding based on what has been also forecasted before during the contract. So this is what we do in Schneider, is really helping our customer in their energy efficiency and decarbonization journey. And this will be even more and more relevant in the EPBD context when all the key requirements will go in this direction. So the technology is available today. Schneider, thanks to a portfolio of solutions, service and systems, can help here and is very well positioned. I would ask Bertrand also to complement how this fits in this compliance context.
Yeah, and I will be very quick because I think I just want to support with some political direction what you said. I mean, first, I think what we show demonstrates the potential of tertiary buildings, of non-residential buildings, because we have those numbers, because they are the kind of buildings where it delivers faster and the highest. So that means that when it comes to the energy performance in building, I mean, the maps is super important, and tertiary buildings having ambitious maps, it's absolutely key for us, because we see a big value which is not necessarily tackled those days. The second point, which has been said already, is the importance of monitoring and to monitor the full spectrum of energy consumption. As a matter of fact, the EPBD concentrate on heating and cooling, plus has a focus on primary energy. And I think this is something we believe should change. Super important to take into consideration the final energy, to also have a PEF conversion factor, which also take into account the fact that increasingly renewable energy sources are being used. And especially in the reform of the energy performance certificates, having a way to show on final energy is super important for us. So that's the second point. And then the smart readiness indicator is absolutely critical, because I think here we are talking about energy efficiency, but what we do is also the foundation for microgrid management, better management of renewable energy sources and the interaction with the grid. And this is where we need a kind of set of indicators that bring a value both for efficiency technology, but also technologies that bring value in terms of flexibility. And last but not least, I would say EPPD is super important with the point I just mentioned. But as smartEn knows very well, we have the market design, the electricity market design discussion today. And demand side flexibility, this is really the elephant in the room in Europe. It has been much more developed in the US, and we need basically energy sharing and access of demand side flexibility and dynamic pricing as well, right? So I think there are also other things that will help the solution to thrive. Thank you.
Thank you very much, Mariangela and Bertrand for this insight, and indeed making the link also with other policies that are ongoing in the electricity market design. And if we really want the values of what the technologies you're offering are bringing, and this value then should be also taken to the next stage, we also need the markets where this is valorized. This is also what Barry was mentioning afterwards. I'm aware of the time, so I will also then move on to the next presentation, our last presentation, but not the least, from Jason from OakTree Power. Jason, please, the floor is yours.
Marion, thank you for the introduction. Thanks everyone for making the time to come to this early morning presentation. So can we go to the next slide, Marion? So I just want to give a brief overview of who we are and what we do. So OakTree is a clean tech company that develops solutions to transform industrial and commercial buildings that have been passive up until recently into assets that are capable of energy management, of reducing their energy wastage, and of providing flexibility services to grid operators. Why is this important? Because every other flexibility provider or market participant is focused on building new assets and introducing new kinds of flexibility into the market. Our view is that there is so much potential just sitting around. As Michael said at his presentation, about 40% of CO2 emissions come from buildings. So there are these assets that are doing nothing but only consuming electricity. And if you could tap into those assets, if you could transform them into active, flexible assets, you could unlock so much support for the energy system without needing to expand your asset bases, without needing to build anything new, all through a simple transformation process. And this is what OakTree Power focuses on. So just a very brief history of OakTree. We're quite a new company. We were founded back in 2020. And even though we're quite young still, we've actually expanded quite fast. We have a portfolio of about 90 megawatts in the UK that is only commercial and industrial buildings. So exclusively demand response and clean flexibility, in the sense that we always prioritize energy savings and CO2 savings as opposed to pure monetary revenues. And this is where we differ from a traditional aggregator in a sense. So even though we're primarily based in the UK, we actually have a presence in about 9 countries. And one of the things that also puts us apart is that our executive team have been in the energy industry for quite a long time. I would say combined experience of at least 80 to 90 years. Our executives were involved in a company most of you might be familiar with it, called QB Power, who were responsible for developing the very first virtual power plant in the UK and also the very first grid scale battery storage in the UK. So we have people at the company, the leaders of the company, who have been front runners in the energy transformation, and this is exactly what we're hoping to achieve at OakTree as well. So come down to the next slide. So this is just a brief description of a showcase of how our process works basically when we go to new commercial and industrial customers. There is one step that is missing here, and that is perhaps the biggest challenge when it comes to creating demand response, and this is education. Because most people don't know what demand response is, most people don't know what energy management is, most people certainly don't know what flexibility markets are. So the 0 step, I would say, is actually education, telling people that you can do energy management. This has no impact on your business as usual, no impact on your internal constraints, like for example your temperature. So you can keep doing exactly what you're doing. The only difference is that you're going to reduce your electricity bill by 30 or 40%, and at the same time you're also going to be supporting grid operators. And the first question we always get is, okay, what's the catch? Because no one believes that this can happen. They always believe that this is too good to be true, and it is one of our responsibilities to explain to them what this new fancy technology is. So what we do is we go to individual buildings and we do a theoretical feasibility study, see what the energy consumption looks like, what devices make it up, and how the building could, in theory, change to generate energy savings. We then send our engineers to the facility to compile an asset list and to quantify with detail how much flexibility potential and energy savings potential can be gained from each device. And if the building is commercially viable, then we install our own hardware and software. This is what we call our Acorn system. We install this at our own cost, and the customer pays nothing. And the Acorn has embedded what we call our LAS strategy, our load adjustment strategy, which is basically an optimization strategy to make sure that the building operates as efficiently as possible, generates as much CO2 savings as is possible, and at the same time, as I said, reduces your electricity bill by approximately 30%. So in a nutshell, you consume electricity for a year, but you only pay for 9 months of electricity. And the way that the company makes money is we get a share from your energy savings and from whatever flexibility programs you may participate in. And I think that this is a key point about our business model, that the only way that we make money is if we save you money or if we make you money. And this is really, really important, because the only way for the company to be successful is for your customer to be successful. And I think that this is a key aspect for the energy transition, that we're all in together. You can't have one party just wanting to make money and basically piggybacking out of bad performances from your clients. We need to work together to make this transformation happen. So let's go into the next slide. And now this is just an overview. I'm not going to spend too much time on it, just to show how, let's say, what a diverse range of assets our technology can work with. So as I said, we're working with both commercial and industrial buildings. So we are controlling traditional assets like heat pumps, HVACs, boilers, chillers at a commercial building, but we can also work with data centers, mining quarries. We actually have clients in the UK that are as small as 100 kilowatts, 200 kilowatts, and clients as big as 50, 60, 70 megawatts in Europe. So there's really, let's say, no limit to how much flexibility you can tap into. The short answer is, how much flexibility is available, we can unlock all of it. Let's go into the next slide. Now, this slide basically describes our let's say the transformation process from a traditional passive client that just consumes electricity to the OakTree client. And as you can see, there are a lot of in-between steps, but I just want to focus a bit more on the scheduling and customization part. So it is basically all the steps that go into designing the load adjustment strategy and then making any changes that might be necessary, because the strategy is designed at the week ahead stage, at the day ahead stage, and then we may also need to make some real-time adjustments depending on new forecasts or new data. And I just want to focus on the amount of information that is available and that we need to actually fully optimize a building. Obviously, we take the common stuff like the historic demand and what the weather may look like. So that's let's say the information regarding the environment. But then we also go into the building itself, and through sensors, we get information like the temperature, the air pressure, the humidity, the CO2 intensity, the occupancy perhaps, and any other information that we deem relevant. So we take a lot of information that then goes into the load adjustment strategy that produces an optimized schedule. So this isn't some heuristic thing that you can just design on paper. This is actually quite a complex process, and even though it may not seem as such intuitively, depending on what season you're talking about, what day of the week you're talking about, is it a work day, is it a non-work day, depending on the occupancy of the building, or if there is some special event like a meeting or anything else that might require, let's say, the building to divert from its normal behavior, the optimization strategy can actually be vastly different. So you need to have access to as much information as possible and to process it as effectively as possible to produce the best outcome for your client. Let's go to the next slide. I'm conscious of time, so I didn't want to talk anymore about the company and the technology. I just wanted to focus more on demonstrating that, you know, this isn't just theoretical stuff that could work. There are actually, let's say, numbers and evidence to back this up. So I'm going to talk about two case studies, two of our clients in the UK. Number one is a Deutsche Bank building in London, with whom we contracted very, very recently. And as you can see here, here we have, for example, on the bottom left, an event from a load adjustment performance from the 29th of October. And as you can see here in this particular case, there were three turn-down events, one in the morning, one during lunch, and one towards the end of the business day. And as you can see, we actually managed to unlock approximately more than 600 kilowatts, so more than half a megawatt of flexibility and energy savings for Deutsche Bank. And just in the third quarter of 2023, so this building has been in operation for about 3 months, we actually managed to save 60 tons of CO2 and the projected annual savings for that are 50,000 quid. So all of us so why is this crucial? Because Deutsche Bank, which also puts a very heavy emphasis on its ESG strategy, continues to operate as normally. There is no disruption to its BU. The building keeps doing what it's doing. No complaints from any of the residents. And as you can see, this is quite a big building, so it has quite a few people. So no complaints, no disruption to the BU, but you save more than 600 kilowatts of electricity, more than 60 tons of CO2 emissions. So this is a win-win-win for everyone. Obviously, Deutsche Bank saves money, so that's a win for them. We make some money and our customer is happy, so that's a win for us. And there are significant CO2 savings, so that's a win for the environment. So this is literally a zero risk and win-win-win solution. So let's go into the next slide. So now this is the second and final case study that I want to talk about. This is another client of ours in London, which is Financial Times, and this actually covers like a whole year because Deutsche Bank was just a quarter. And this case study is meant to showcase just how much potential there is in commercial and industrial buildings just sitting around. As you can see, for example, at the bottom of your screen, in 2022 we actually initiated more than 900 events of demand turn down. So which corresponds to about 900 hours of flexibility and energy savings. I'm not going to focus so much on the 40,000 of annual savings. I'm mostly going to focus on the 230,000 kilos of CO2 reduction that we save. And so this is just, again, this goes back to my initial point that there is so much potential just sitting around. See here, about 1,000 hours of flexibility, 1,000 hours of energy savings that are so easy to implement, but that were never part of the building strategy. Number one, because the building managers don't necessarily care about energy efficiency. They don't really know how to do energy efficiency and are not knowledgeable enough to do energy management in a sophisticated manner. So this is just meant to show that if you know what you're doing, even if your process is simple, it's as simple as just turning off non-critical assets during key times, you can save so much on your electricity bills and so much on your CO2 emissions. And one final point I want to make is this is the middle bar that talks about a 5-year flexibility agreement. I've been hearing a lot of talks from my colleagues about flexibility and how important it is to unlock the flexibility of buildings, but the reality is that in Europe, when it comes to especially commercial buildings, providing this flexibility potential to grid operators is not always straightforward. Sometimes there's a lack of a regulatory framework. There is a lack of a market. The system operator may not be up to date yet. For example, many of the DSOs still do not have an active flexibility market in Europe. I would say that this is the majority. Portugal is one exception, and I know that we have someone from the DSO in Portugal who's going to tell us a bit more about local flexibility markets. But in this particular case, the UK is a front runner when it comes to local flex. UK Power Networks is the distribution system operator in Greater London and the South and the Southeast. They are actively engaging with demand response providers to manage congestions in their system and to save money on reinforcement deferral. And Financial Times, other than doing a lot of energy efficiency, again, about 1,000 hours during the year, is also working with the local network operator to match those energy efficiency hours with times when the grid is at stress, to provide flexibility services and help just by being energy efficient. So just by doing what's good for your electricity bills and for the environment, you're also helping the grid operator. So now you're introducing a fourth win. It's a win-win-win-win, if you like. So just by doing a simple transformation process, you can help 4 different parties, and this is why I think this case study is so important. I think this is my last slide, Marion. I don't know if I have another one. Yeah, okay. So yeah, so thank you all for your attention, and if you have any questions a bit later, I'm happy to take them.
Thank you very much, Jason, and thank you very much also to the 3 other speakers. We are a bit over time, so I would invite the participants who have questions to write their question down to the chat, and then we will forward them to our speakers, so then you can also be in touch. But this is a good overview that we had on the technologies and looking at the different type of building, residential, commercial, industrials. Now we know that those solutions are there. How we make sure that we have this data also used at system level. And for that interesting discussion, I will give the floor to Simon as the moderator. Simon is also the chair of smartEn Active Building and Neighborhood Committee, and he will do an excellent job in the discussion with the system operators today. Simon, please go ahead. The floor is yours.
Thank you, Marion, and thank you for your confidence. Good morning, everyone. It's really great that we've covered both domestic and commercial solutions this morning. And I was particularly taken by Jason saying just now there are thousands of hours available in buildings at the moment. But active buildings, that is buildings that are a part of the grid, can only do that if that information is provided to the system operators. So information is key, and hence this session with the system operators. Now, to just give it a little bit of context, the executive director of the Smart Energy Demand Coalition, going back those days, Agustin and I, we first wrote a paper on this subject several years ago, and it's absolutely brilliant to see how this topic is now developing. And in April, at smartEn's Forum on District Self-Balancing, 3 system operators talked about the importance of flexibility in meeting their challenges. And then again, in September at FlexCon, Elenia talked about the new normal of demand following generation. And Annexis talked about demand growing faster than the ability to strengthen the grid, and that the need for new solutions is growing. And then the recent announcements on the electricity market design have introduced the concept of energy sharing as a basis of district self-balancing. So all in all, momentum is building. Today, we're carrying this on with having discussions with 3 innovative system operators on how data on actual performance of buildings can support them to optimize their use of the grid by shaping market-based mechanisms to activate the flexibility from connected buildings, some of which we've heard this morning, and to better plan investments in the grid. So we have with us today Luis Cunha, who's the Director of European Policies and Projects at EuroACE, who's the main DSO in Portugal for high, medium and low voltage networks. Good morning, Luis. Luis is responsible for the coordination of European activities and funded projects. He's a board member of the EU DSO entity, vice chair of the ETIP SNET, so many acronyms, and an active member since its foundation of EDSO, formerly EDSO for Smart Grids. He also actively participates in European forums and platforms relating to the energy sector. We also have Tomi Mäkelä, Energy Data Manager for Elenia, a Finnish DSO, the 2nd largest in Europe, serving around 450,000 customers and over 100 municipalities. Good morning, Tomi. And Carl Cook from Elering, an Estonian gas and electricity TSO. Carl has worked for Elering since 2010 His current focus as senior advisor is on TSO-DSO cooperation, system flexibility. And Elering is involved in the OneNet project, a European project that aims to improve the access of flexibility on electricity markets, and the interface project leading the development of the regional market platform for flexibility services. So welcome to you all. The first question is, you're all exploring how to use performance data at the moment. So can you tell me, what are you doing to right now with this data? So Louis, can you start with you, and particularly your Interconnect project?
Okay, first, thank you very much for the invitation. It's a pleasure to be here and sharing a little bit of our experience with you and other colleagues. So when referring to data and to projects, first, starting from the project's perspective, what we are doing now, we set a strategy, I must say, maybe 4 or 5 years ago. And the idea was pretty simple. So the idea was to make sure that DSOs were able to connect to as many flexibility system providers as possible, making use of any available resources. And in order to do that, we basically worked on 2 different topics. One is the connection with the flexibility market platforms. And for that, we are running a project that is reaching the end right now, which is called Universal. And we have developed a solution that is called UMI. The UMI is a set of simple APIs that allow DSOs to connect to any kind of market flexibility platform and to get flexibility from that. And on a different level, we are also working on the direct connection with the buildings and consumers and appliances and things like this. For that, we are taking part in a project that is led by Hashtag, which is a project called Interconnect, where we are trying also to define the ontologies and the ways to go directly to the buildings and to the devices connected to consumer. We see this as a crucial step because if we go back a little bit in time, we also generated in 2018, if I'm not wrong, a report from the DSOs at European level speaking about the role of DSOs in flexibility and what we need in order to promote its use. And basically, we came to the conclusion that we need to have as many tools as possible to manage flexibility. In that sense, I think it's quite important that we find clever ways to access those resources and not to limit the market, because I think there is, as mentioned in a previous intervention, there is a lot of potential already sitting there. And what we need to do is to make sure that we have simple and easy solutions to put consumers working together with the networks in order to have an efficient and affordable system. Of course, I can go into details at the national level. We have been doing a lot of things. One on energy sharing, we have now 2 pilots running with our regulator. And one of the pilots is very interesting because we give the opportunity for the communities to define whatever coefficients they want to play with for the energy sharing between them. But basically, what we would like to see in the future is something that leads to a responsible participation of every partner in the process. What I mean by this is that I think that we need to organizing also the system in a bottom-up approach. I mean, we spoke a lot this morning about energy efficiency. That is also reflected in the Energy Performance Building Directive, and the energy efficiency first principle is indeed a very important one. So I think the first thing to do is to make sure that buildings, and now we are thinking about buildings are well balanced and are efficient in the way they make use of the energy that they generate, they store, and they consume. This is of crucial importance for the system operation. Having said this, I think we need to move to the next level, and the next level is the community level. And at that level, we also need to promote ways to make sure that the energy that is generated at local level stays at local level. That is what we would like to see in order to avoid any kind of special problems in the technical problems, voltage congestions and things like this, and also to avoid network losses, which is becoming an important topic also for system operators. And then we move up in the value chain, and then we go into the distribution networks and the transmission networks and so on and so forth. But basically what I'm trying to convey is that this relationship between the network and the edge, in this case here, in this discussion represented by the buildings, is of crucial importance to manage the system. And what we are trying to do in our environment at national level, and also at European level, is to find ways to cooperate with the building managers and the building energy systems to have a two-way approach or a multiple-way approach. It's not only the DSO that needs data from the buildings, but also the buildings that needs data and signals from the DSO. And from that perspective, we are also cooperating with the European Commission on this a framework for a common reference framework for an European energy app that will allow us to send signals directly to consumers whenever there is the need for them to participate in a volunteer way in this flexibility market. So this is also something that we are doing under the Interconnect project. It was also referred here when introducing Cale Kolk that he is playing also an important role in the OneNet project. We are also working on that project. And in that particular project, we are coordinating our activities with the TSO, extending this capability of exchanging flexibility. So I think we are doing quite a lot. But for me, what is really important is that we discuss these things together. I mean, with the people that are running the buildings, the ones that are introducing solutions for the buildings, because we need to make things simple, make things interoperable, not put too much complexity on that, take all parties on board. Just to mention, to finalize my introduction, we are now discussing the reform of the energy market directive, and we see there the possibility of having multiple contracts inside the same home. That will create additional complexity, but I think it's something that we can solve, and it's something that can empower consumers. But that will extend the relationship and the multiple parties that need to understand each other. So it creates a complex environment that we can only solve through cooperation and through simple solutions. I think it's all from this first intervention. Thank you, Simon.
Thank you, Louis. That's really encouraging. And I agree with an awful lot of what you're saying, and about we need this bottom-up approach and two-way communications. You've stolen a bit of Carl's, what he was going to say about the OneNet project, but Carl, can you follow on from that and tell us what you're doing?
Sure. Hello, everyone, and thanks for inviting. Right to the point. So in our corner of the OneNet project, we are working on the regional flexibility market concept. So it involves several countries. We're defining the flexibility products, we're defining the tools, we are defining the processes, which would be common for all the countries participating. And furthermore, we are defining in that way that both TSOs and DSOs can participate at the same time. So any flexibility coming to that market can be used for any system operator or for any need like balancing, congestion management, etc. And we do it around the concept of the flexibility register. So this is the kind of solution where we can collect all the information about all the participating flexible resources, and where we can collect all the measurement data of those resources afterwards. And by doing all that, we have a special focus on residential buildings as well. And we try to do it in a way that all and any flexibility can participate on the equal ground. Thank you.
Excellent. Thank you for keeping it short as well. Tomi, last but by no means least, would you like to tell us what you're up to in Finland?
Yes, and hello everyone. In Elenia, we have ongoing next generation smart meters rollout project, and we have installed now about 50% our customer smart meters. And these next generation smart meters measure 5 minutes customers' consumption and production. And the smart meters push every 15 minutes this data for us, meaning that we know customers' 5 minutes average power after 15 minutes, and also customer see their 5 minutes consumption after 15 minutes our extranet. And Now we are also developing real-time network calculation based on this 5 minutes average power. And our goal is that we know quite real time if we have bottlenecks in our networks in the future. And also in Finland, we have connected customers' loads to the relay of smart meters, for example, water heaters, heat pumps, and electricity heatings. And our customers which has the next generation smart meter can control the load through our control service. We published this service for our customers about 3 months ago. And customer can choose hours where the relay and loads are on or off, or they can choose controls according to Nord Pool's day-ahead spot prices by choosing how many times or hours the load is on. And the next step is that electricity market operators or retailers can control customers' load via next generation smart meters. And actually next month in December, a project will start in Finland where transmission system operator Fingrid, electricity market operators, DSOs, will define together the load control interface. And this project will be done by the end of the next April. And the goal is that electricity market operators can control customers' loads behind the relay of the next generation smart meters from the beginning of the 2026. So we have many projects ongoing at the moment.
So lots going on, and it's really good to hear that and things. But I suppose one of my next questions is, how can we improve this? How can we make it go faster? Is there a role that smartEn and our members can do with you to help you move faster in this market?
Well, we already cooperate with a smartEn member, Digital for Grid company. We exactly cooperate with them in the OneNet project already. So they are equipping some households, some houses in Estonia, as well as in France, as a kind of test houses. And inside that, they have several controllable devices, which they monitor in real time and which can provide flexibility. So this is what we are doing right now.
Excellent. Louis, do you have any thoughts about how we can?
Yes, I think it's a very interesting question, very difficult also to reply. From a technical perspective, I think that one of the problems that I see in front of us is exactly to make sure that we can communicate and get access to the data. I mean, not only the data that we get from the buildings, but also the other way around. On the side of the DSOs, we are rolling out, I mean, the ones that are doing that, we are rolling out the smart meters and providing the data, and I think that should not be a problem at all. From the building side, I think the situation could be more complex. What we see in certain projects is that any vendor out there is creating its own clouds of data. That means that in the end, if we want to access data from a device that is inside a building, a charger from electric vehicle or even an appliance, that will become a difficult topic, I would say, because then we have the vendor of the machine. This is also a complex problem from the household level and also for the people managing and running the building. So we have the one that is providing the appliances, we have their cloud, they want to make also their business on top of that. And then we have the aggregator or the building energy management system. So there is a lot of people sitting there in the value chain that makes, from a technical perspective, the system a lot complex. So that means that we need to find simple ways, not complex standards, but simple ways to interact without putting too much effort on that. And we also need clear rules for data governance on that to make sure that data is accessible, is available, preserving the security and also the right for the ownership of data.
Okay, really interesting. So a couple of additional questions for you, Tomi. How current does this data need to be? Are we talking historical, or is it more important to get access to hourly or half-hourly data? And along with that, how important is it to have an intermediary, and who do you think those intermediaries are? Because I can see that from what Louis was talking about, talking to each individual building or each individual equipment in the building is the massive problem. So how do we get through this bit?
First, I have to say that is not a problem in Finland now, because the smart meters can measure 5 minutes consumption now and push it 5 minutes after 15 minutes for us. So this is quite real-time information that we get about the smart meters.
But that is consumption data. We're talking here much more about the energy performance of the building, and in particular, what sort of flexibility is available. And so it's that sort of aspect, and that is hard to get from raw smart meter data.
I think we can quite well analyze the consumption and I think we know about this consumption or profile, how much there is demand response capacity in these households or buildings.
So is that your view, Tomi, then, that the DSO can do it all themselves? You don't need any additional help?
Of course, if we get something more help or information about it, that is really good for us.
Carl, what's your view? Do you think there's a role for other players in this market?
Well, I think the normal smart meters, the main meters at the connection points to the grid, I think they will be more and more just for the reference value. And actually, we will rely, and we already do rely on what we call submeters, which is the measurement on the individual device or resource level. So we do that already, and this is something which is not directly controlled by the system operator. It's normally in the domain of the aggregator or technology provider or the consumer himself or herself. We need to trust them, and maybe I think maybe it's a good point to make a link to the energy performance certificate of a building, which we were talking earlier today. So it can be used, the certificate as such can be used for the long-term planning, I agree, but I'm also looking for the ways maybe how to use it for the flexibility market. And I see at least one way to use it. So it could efficiently replace the pre-qualification of the assets. If the certificate is strong enough and it can confirm us as system operators that also all the devices there are well controllable, they are there in first place, they're controllable, they can be monitored in a trustful way, then I think we as SOs, we can escape from the actual pre-qualification.
Yeah, thank you. Time is marching on, but I do have one question from the audience. So I'm going to ask Louis to answer this one. Do you think that the DSOs need more of an incentive structure, to ensure the necessary investments are made to allow for the maximum interchange of building flexibility? Are there changes that are needed to EU rules in this area, or do you think the current rules are sufficient?
Let me try to understand better the question. So the question is if we need any kind of incentive to invest in better solutions to interactive buildings. Am I correct on this?
Additional incentives, I think.
Yeah, okay. Well, I think we don't see it necessarily that way. I think we are rolling out digital solutions. So as mentioned, so the smart meters. But what worries is that when it comes to investment, I think, again, we need to have a balanced approach. My point is that every partner in the system need to cooperate, and we need to find clever solutions for that. So flexibility is for sure one of the solutions that we are exploring. But flexibility is not a panacea, it's not going to solve everything. I think the first and most important topic is to make sure that every participant in the system is responsible. That means that the building operator is responsible for ensure local balancing as much as possible. This is a crucial step, as I mentioned in my first intervention. But then, having said this, of course, we will going to have faced different problems. And what is happening now is that when we go to the household level, I think we are mixing now different sectors. So we were not used to charge our vehicles at home, at household level. Now we do it, and the drivers for charging the vehicle are not the same that are for cooking and for washing the clothes and things like this. So we have different drivers and different behaviors, and we need to coordinate these different behaviors in a clever way. And for that, I think it's really, really important that we make things interoperable. I mean, the system operator needs to communicate with the buildings, and the buildings also need to communicate with the system operator. And during a decade or 2 decades of our lifetime in our sector, it was almost forbidden for DSOs to have any kind of interaction with consumers apart from the meter. But now we see that even the Commission is pushing further for this. And I agree on this. I think we should not create a technical problem around that. We should speak together about how to facilitate. And of course, in the end, this will apply investments, that is for sure. I don't want to go into the topic of investment because I think it's a different one. But at least, again, going back to my first message, I think is the most important one is that we should cooperate together without taboos, discussing the topics, the submetering, the multiple contracts, the interfaces, the APIs, the clouds of the owners and the vendors of the solutions, how to put all these things operating in order to facilitate the energy transition. Because I think in the end, the resources are there, people behave well when they are oriented in that way. It's on their interest also that they behave well, also to cooperate with the system. So if we can do it together, let's do it. That is my message.
Well, thank you very much for that. I'm afraid we are out of time now. I shouldn't have asked the last question, never mind. So thank you very much for everybody, and really interesting stuff. And let's keep communicating and keep talking. Thank you.
So good morning, everyone. I have the honor of closing out this webinar. I'm Adrian Joyce, Secretary General of EuroACE Energy Efficient Buildings, and it's been a real pleasure to co-organize this really engaging webinar with smartEn. Mäkelä started by saying energy efficiency in buildings and demand-side flexibility go hand in hand, and here at EuroACE we agree. And I think that the presentations we've seen this morning demonstrate that very clearly. I saw also that it's absolutely evident that digitalization is coming in its many forms, and that it will become more central for energy efficiency performance of buildings. And we've learned that the monitoring of real performance is essential, and that the gathering and sharing of data is crucial. But what I took away as well is that those digital and flexibility solutions are highly reliant on energy efficient or highly performing buildings, or at least that when you have highly energy efficient buildings, these digital and flexibility solutions work a whole lot better. I particularly liked the part of in the examples where the demonstration of how you can shift heat demand in cold, calm winter days can really help in a factor of 5. I think it was in the Knauf Energy Solutions presentation. Finally, I think we heard with the DSO's debate that a two-pronged approach is going to be needed moving forward. The top-down approach through good, coherent, ambitious legislation across the building sector and across the electricity market sector, but also a bottom-up approach where activating customers through attractive offers and building a community spirit really between at district level for sharing resources is going to be crucially important. So on those few thoughts, and on the thought that really we're talking here about cooperation between people and cooperation between data or technical installations, I leave you and wish you a very good day. A final word to thank the organizers, my colleague Avramidis and those at smartEn. Have a great day, and please share the recording of this webinar with your network. Bye for now.